Okay, so in this video we're looking at getting started with the software development kit for the ESP8266. We're going to be using Windows, but as it runs on Linux we're going to be using a virtual machine, and that allows you to program the ESP8266 in C and get to grips with sort of the low-level functions of the device. So let's get started. The first thing we're going to do is download and install VirtualBox. Here I've done that already. It's a free program, but I'll put a link of how to install it below. The next thing is we can navigate to the ESP8266 website and download the virtual machine image for the SDK. I'll put a link to that below as well. It comes up with a Google Drive with all of the documentation and also the image, and you can just click to download like so. Once that's downloaded, you can click on it and import it to VirtualBox. It'll come up with the various options, but you can just run through, and it'll take a little while to import the appliance. Once the appliance is installed, we can create a shared folder which is shared between the host computer and the computer which is running the virtual software development kit. So we can go to shared folders and set up a shared folder wherever you want the path to be, and that's where the binary files are going to get put, which we're going to flash onto the device. Once we've done that, we can start up the machine running, and you'll see that is an Ubuntu variant. I'll just open the documentation as well from the Google Drive file on the right. If we open up the terminal, we can mount this shared folder that we're using, and the root password is expressive as in the documentation, and they're the vendor of the ESP8266 chip. I'll put the instructions here. The next thing we can do is, using this link which is found in the documentation, navigate to GitHub and download the latest version of the software development kit. So we'll download this in the host Windows PC, but we can move it over to the shared folder so that it's visible on the virtual machine. So here I'm just extracting the folder. So that we have all of the directories required for the SDK in that shared folder. We can then go back into the virtual machine. and navigate to the shared folder where the SDK files are. So looking through the files, you can see that there is some examples. There's the AT command example, which is pre-installed on the ESP8266, and there's another folder called IoT demo. So in the root directory we have a folder called app, and that's the application which is going to be compiled for the ESP8266. So what we can do is copy the examples file using that command into the app directory, and that will copy that example for compilation on the ESP8266. So we can go through the stages listed in the documentation. We can call make, followed by gen misc shell script, and we can see that's been successful. And then looking in the shared folder, we can see that a binary file has been generated. Now, in order to flash this binary file to the ESP8266 device, we can download a flashing software from the internet. Here I'm using Flash Tool, I'll put a link below, and you can just download it and install. And there's a password to unzip it, which is Electro Dragon, the software vendor in this case. Once this is unzipped, we can just open up the tool, and you'll see the flashing tool there, where we can specify the different binary files which are to be flashed to the device. So let's go through a hello world example where the device flashes an LED on and off. So we can go to the GitHub code examples page. You'll see there's a blinky example which just toggles one of the GPIO ports. So if we download that, okay, so then we want to copy the user folder into the applications folder, so that's got both of our source files in, and we'll now see that the application is replaced with the blinky application. So moving back to the virtual machine, we can see that we can change into the user folder. And we've now got our new header file and main C file. We can then make the example. And then run the provided shell script as well. We can run through these options that are provided using the default values. now, and then the build is complete. It'll tell us that we've got 2 binary files and the hex locations at which they need to be flashed. So if we open the binary folder, we'll see the 2 files. And we can see in the shell the 2 locations they need to be flashed at. So we can open the tool for flashing the device, load in the binary files that we've just generated, and enter the addresses. Here I've made a little board to flash the ESP8266. It's just the device and then a couple of toggle switches with resistors, but I'll put a schematic as well on the website with a link below. So we plug that in with Serial Programmer. Press the button to indicate that we're flashing, and then we can start from Windows, flash the device. Okay, so here to check the flash has been successful, I've just connected a crocodile clip to the GPIO pin which we're toggling via a resistor through an LED, and we can see that it's flashing according to the program which we've written, so on and off. Okay, so thank you for watching. I hope that was helpful. Please do like the video if you enjoyed it, or even better, subscribe to the channel for more videos in the future.